this is the law of sines and how we derive it. In the applications, we will have two cases, angle, angle, side, and side, side, angle. The easy one will be the side, angle, angle, side. Now, we were working on this number 4. I said earlier, for us to be able to apply law of sine, we need to have one pair. Now here, we don't have one pair yet, but we can easily find the other pair because, see, the sum of the angles in the triangle has to be 180 degrees, right? Okay, so angle B is, angle C is
90?
Huh?
90?
No, it won't be. A plus B plus C should be
180.
180. Okay, so 35 degrees plus 35 degrees plus C equals to 180 degrees, right? So 70 degrees plus C equals to 180 degrees. So C is 110 degrees. Is it okay? And then, so let me put it there. This is 110 degrees. By the way, when we say we need to solve for a triangle, solving a triangle means you get all 6 values of these informations here, all of them. That's what we mean by solving a triangle. Okay, usually when we solve a triangle, we are given 3 of them and we need to look for the other 3. Okay, that's what it means to solve a triangle. It means you need to find all 3 angles and all 3 sides. Okay, now that's for us to find these 2 sides, we need to first find that C. Now, once we have this one pair, then we can apply law of sine. Okay, now then to use law of sine, let's find side A first. Side A is side BC, the opposite of angle A, right? That will be sine A over side A equals to sine C over side C. When you apply law of sine, I want you to write the formula first, okay? Yeah, and then sine 35 degrees over A equals to sine 110 degrees over 16. Can you compute that for me? What's A? It's 16 sine 35 degrees over sine 110. What do you get?
9.7661.
9.766
20.
5 decimal places, right? And this will be in centimeter because this 16 is in centimeter. Okay, so let me put it back here. That will be 9.76620 centimeter. Okay, then you can do the same computation for AC. Okay, you can do the same computation for AC. Side AC is also side B. And then you compute. Okay, while actually, if you think about it, you don't need to compute because there are some rules from trigonometry, from geometry, triangular geometry that we can learn, note. And these are important notes, by the way. The first one, something we already know, the sum of interior angles of a triangle is 180 degrees. That's something we know, okay? Second, in a triangle, in the same triangle, the longer the side, the larger the opposite angle. Vice versa. Okay, so the longest angle in this case, you see that the longest angle, the longest side is 16 centimeter. Okay, the angle is the largest. So earlier, even before I get this 9.6 up 9.7 something, even before that, once I know that this is 110 degrees, which is the only obtuse angle possible. In a triangle, you can have at most only one obtuse angle. Now, because that's an obtuse angle, then this side must be the longest one. Okay, so I know my answer for BC and AC has to be less than 16. Are you with me? The longer the side, the larger the opposite angle. The larger the opposite angle, the larger the angle, the longer the opposite side. Now, because of that principle, then what happens if you have the same angle? Because angle A and B are the same here, then the opposite side must be the same also. Okay, so you can work it out there, or you can also say side AC is equal side BC because which is 9.76620, and because the opposite angle, angle A equals to angle B. Are you with me? Now that knowledge is important for our later work. Let's say, for example, number 8. Number 8, side A is 52.15 centimeter. Side C is 42.90 centimeter. Angle A is 125 degrees. And the question is, find the remaining sides and angles of a triangle. So I need to find side B, angle B, and angle C. Okay. Now notice that this is already the obtuse angle. So the other two angles has to be less than 90 degrees. Why? Because if any of them more than 90 degrees, then it will be more than 180 degrees already total, right? In fact, the angle for each one of them should be less than 55 degrees, if you think about it, right? Okay. Now, but then let's proceed with computation. Let's proceed with computation. Which of these three we can find first? Angle B, angle C, or side B? Which of these can be done first? What?
Find B.
I can't hear you clearly. We have one pair here. We have one pair
We're gonna
here.
find angle C first.
Yeah, we need to find angle C first. That's what we will do first, okay? That's what we will do first. So first step, I will do angle C. To find angle C, I will apply law of sine to A and C. Now, sine 125 degrees over 52.15 equals to sine C over 42.90. So sine C will be 42.90 sine 125 degrees over 52.15. Then you use your calculator. You do it together with me, please. I get sine C equals to 0.67386 centimeter. I'm sorry, no, not yet, not centimeter yet. That's sine C. That's sine C. Actually, then what will C be? C is sine inverse of that number, right?
Mm.
Yeah, but don't forget, sine is positive in two quadrants. If I use sine inverse on this number, then I will get the angle in the first quadrant. Okay, and how about the angle in the second quadrant?
Too large.
Let's get it first, then decide.
Oh, I'm sorry.
I get 180 degrees minus C1, whatever I get earlier. I
One.
get 137.63458 degrees. And then you cross it out. And then you cross it out and you say A plus C2 is already greater than 180 degrees. Okay? You cross it out, you give it first and then say what's wrong with that. Okay? That's how you show that, you know what, the answer for these, they are actually two angles, but one of them not applicable. Okay? So let me put it back there. That's 42 point, that's 42, no, I don't use this. That's 42.36542 degrees.
When
Now,
yeah, when I did my calcul, I got minus negative 0.506.
Did you do it in degrees? Did you check, can you check?
Yeah.
It's in degrees?
Yeah, in degree. Yeah, okay. So I have to put my calculator in degree.
Yeah, just make sure that when you work in degrees, then the mode of your calculator is also in degrees. Yeah, okay. And then let me ask you to do from here, what can you do? What is next from here? So this is the first thing you do. I believe this is your second, right? And then this is your third, right? Okay, let me ask you to do second and third. So second, find angle B. I think that one is easy, right? Okay, and then from that B, you will find side C. I mean side B. Okay, let me give you 1, 2, 3 minutes. part B, I get 12 degrees something. I think that one is straightforward, huh? Now then to find side B, let me write it down. This is 12.634 by 8 degrees. And then for part B here, side B here, that will be sine 125 degrees over 52.15 equals to sine 12.6345 degrees over B. So B will be 52.15 times sine 12.6345 degrees over sine 125. And then 52.15 sine 12.6 3, 4, 5, 8 divided by sine 1.5. I get 13 something. 13.92523 centimeters. I put it here, 13.92523 centimeters. Okay, now that's for number 8. Actually, for this number 8, unintentionally, we have been working on, if you take a look on the black part, we are working on the situation where we have 2 sides and 1 angle. Do you notice that? And when we are given 2 sides and 1 angle, you see that we will always have this equation. 2 sides, 1 angle. So the other angle, okay, the other angle may be giving us 2 possibilities. Okay, it may give us 2 possibilities. Now then from there you will check which works. It is possible that both of them work though. So if both of them works, then we will continue in our step 2. Instead of only 1B, we will have B1, B2. And side B later on will be B1, B2 also. Okay, now for that example, for that kind of situation, let's take a look on number 14. Number 14. And I also would like you to notice that I always arrange my information this way. Angle A, side A. Angle B, side B. Angle C, side C. On the top of each other, like that. Okay, that way it helps me to see what I know in organized fashion. Angle A is 20 degrees. Now the question is part A. Part A, show that angle B has 2 possibilities. Show that angle B have 2 possibilities. So yeah, of course, given this situation, we need to find angle B first anyway. Is it right? Okay, let me ask you to do that. After you get angle B, there will be 2 possibilities. You will see that B1 and B2, and both of them possible. Now then later on, your angle C1, your angle C will be C1 and C2 also. And you have side C1 and C2. Okay, let me ask you to find angle B and show that there are 2 angles satisfying that situation. Oh, by the way, because the sides are 30 and 36, because the sides are 36, then we see that angle B has to be larger than 20 degrees. Does it make sense? Okay, so angle B has to be larger than 20 degrees because side B is longer than 30. B is 0.4104.
Are you asking for the answer now?
Yeah, let's do it together. So sine inverse of this guy is
It's 24 point.
24.23148 degrees,
Yes.
right? And of course, our textbook rounded to 2 decimal places only. But then for angle B, this 24 is checked, right? This 24 is checked. The checking is because we know earlier that angle B has to be greater than angle A, right? Because side B is greater than side A. Okay, and then also A plus B is still less than 180 degrees, so it is acceptable. Okay, now how about B2? B2 will be 180 degrees minus B1. That will give us 155.76852 degrees. And it's still okay because it satisfies both requirements. Okay, B2 is 155 while A is 20, so the sum is still less than 180 degrees. So here we have two B's. The first one is 24, 23.23, 148 degrees. And the other one is 155.76852 degrees. Now then, once you get that, let's go on to part B. I would like you to find angle C1 and angle C2. Do them separately. And if possible, don't do it on the top of each other. Do it next to each other. The plan is once you get your C1 later, then once you get your C1, you will work the side C1 underneath and side C2 underneath, like that. It's about organization so that you don't get confused. Okay? Yeah, work it out, please. Let me ask you to find side C2, angle C2 and side C2. I will work on side C1, angle C1. Or which one would you like to do? I don't know, I get confused. Would you like to do 1 or 2?
1.
Okay, you do 1, I do 2 then. You do this, I do this. Okay? So side C2, A plus B2 plus C2 is 108. Okay, what you get for your C1?
135.76852.
76,852 degrees. Anybody else can confirm?
Yes, it is.
Okay, now then, how about side C1?
61.18577 centimeters.
61 point.
18577 centimeters.
There's no centimeter here.
Oh,
Well, anyway, you get the number. Can somebody else confirm this number? Yeah, I get the same number. Okay. So then that way we get angle C1 is 135.7685 degrees. And then side C1 is 61.18577. Now that's for question B. Now, the follow-up question is actually a very good question. Part C, find the area of the triangle. Find the area of each triangle. So let's deal first with the area of triangle 1. Area of triangle 1, don't forget that we actually start with the formula. We have the formula 1/2 the product of two sides times the sine of the included angle, right? Okay, we are given two sides here. We are given two sides, sides A and B. Okay, so the difference will be with angle C1 or angle C2. Is it okay? So area of triangle 1 will be half AB sine C1, and area of triangle 2 will be 1/2 AB sine C2. Okay. Now you do yours, I do mine. You do the first one. I think that's 30 times 36. Sine what again? 135 something. 135.7685 degrees, while mine will be 1/2 times 30 times 36 sine 4.23148 degrees. My area is 39.84452. I wonder what you get.
I got like 753.36360.
300 what? 70?
753.
Don't forget divide by 2.
Oh, divided by 2. 376.68180.
Okay, good. So one lesson, don't forget to divide by 2, okay? That's half of the product of two sides times the sine of the included angles. Now that's for the law of sine case. Law of sine, that's the law of sine case. Suggested homework from this part here. Suggested homework from 9.1a will be number 1 to number 15 is actually a good question. Okay, now you don't need to do all auto. Again, it's just try to pick the ones that you know what, let me try this question, let me try this question like that. Okay, and this section 9.1 is actually not supposed to be separated this way, but I want to emphasize the different treatment we do for law of sine and law of cosine. Now, of course, then after that, we will put them together. Okay, after that, we'll put them together. Now, we go on to 9.1b. 9.1b, I present the proof for law of cosine here. Now, law of cosine is actually as the following. I have, let's say I have given two sides of a triangle. Let's say this is side A, and then this is side B, and angle theta here, and angle theta here. Let's say that's the one given, and we need to find out the length of the opposite side of theta. Okay, that's not a good. We need to find out the length of the opposite side of theta. So what is this? Now, the way our textbook prove it, I think that's the way our textbook prove it. I don't remember precisely. It may be different. Well, anyway, this is how I prove it. This is how I prove it. I actually impose this A and B on coordinate system. Okay, so let's say I put side A at angle 0 degree, side A at angle 0 degree, then the coordinate A here will be A comma 0. Okay, I'm not supposed to call that coordinate A though, but let me just call that coordinate A for now. Okay, and then side B, I make it in the way that the distance from origin is B at the angle of theta. Okay, now because the length is B angle theta, consequently the coordinate is given by this. I wonder if you remember the unit circle approach. If I have unit circle, oops, no, that's not correct. When I have unit circle, let me use the count. When I have unit circle, okay, and then let's say this is the positive x-axis, and let's say this is the angle theta here. Okay, now because the radius is 1, it's unit circle, so the coordinate for this, knowing that the angle in standard position is theta, then the coordinate here will be cosine theta, sine theta. Remember that? Cosine theta for the x component, sine theta for the y component. Now, extend this by factor of b. If you stretch that by b, then the coordinate here will multiply by b. You see what I mean?
Can you do this in a question?
Repeat again.
Can you do it in a question?
Can you what? I can't hear you clearly. That's the thing.
She said, do it in a question, please.
Do it in a question. I'm still doing the proofing for now. And I'm still reviewing what we have done 2 chapters ago. Now, 2 chapters ago, we learned that if I have a unit circle, and the angle here is angle theta, then the coordinate here must be given by, if this is theta, then the coordinate here must be given by cosine theta, sine theta. Now, the thing is then, what if I stretch this circle instead of unit circle, I make it length b. So this is now b, this is now b, this is b cosine theta, this is b sine theta.
It would be as if
basically you enlarge that circle. Okay, now the key point is like what happened to this coordinate. Okay, now then I go back to what I have here upstairs. Okay, so if this is angle theta, then the coordinate here will be, coordinate B cosine theta, B sine theta. Now, then this side C here is basically the distance between point A to point B. There I applied distance formula. So C squared is equal to the difference in the axis, the x component of B and the x component of A squared plus the y component of B minus the y component of A. Now then I do expansion, I FOIL these, I get these three terms here, while the other parentheses you subtract by 0, so nothing to be done, right? Nothing to be done. Now then in the next step, I combine this guy with this guy and I factor the B squared. Now, notice that sine squared theta plus cosine squared theta is B itself. Now, this is the law of cosine. That's law of cosine. Now, in a triangle, therefore, if I redraw the triangle, let's say this is side A, this is side B, and this is angle C. Side A, side B. Then side C is the opposite of angle C, can be computed using that formula. Two sides and included angle give you the opposite side of that angle. Okay, so side C squared equals to A squared plus B squared minus 2AB cosine angle C. Notice that the side in the opposite of the angle. Okay, the side is in the opposite of the angle. Now, with that said, then we are ready to apply this. There are two applications of these formulas, though. The first application is in the case of side angle side, the one that we have just now. Two sides and the angle is in between. Two sides and the angle is in between. You see this angle here is in between those two sides. Okay. Now, so if we have this situation, you can apply law of cosine. And actually, the other application is when you have all three sides. Imagine if I have side A, side B, and side C. Then I can find angle C. Okay. To say it another way, in case that you have of this 6 component angle ABC, side ABC, if you cannot use law of sine, then you must be able to use law of cosine. Okay? Law of cosine completes or finishes what law of sine cannot do. So in a situation that you say law of sine is not doable, then use law of cosine. In fact, you will see later on, I don't know when, you will see later on then law of cosine is actually slightly more powerful than law of sine. Now, let's do some problem. Let's do some problem. Let's take a look on number 28. Number 28, they actually give us picture. So we have this situation here. If they give you a picture without labeling, try to label it yourself, okay? Of course, you can just go ahead with the problem if you like, but what I have in number 28, this is 4 centimeters. This is 30 degrees. And this is 10 centimeters. Find x. Okay, let me ask you to apply that. Apply law of cosine to find x. Write down the formula first though. Actually, no, you don't have formula. Just apply the formula right away. You see this x is the one we are looking for, the size that we are looking for. Okay, and the other two sides are 4 and 10. So I get 4 squared plus 10 squared minus 2 times 4 times 10 cosine 30 degrees. Okay. Then from there, you use your calculator. Whatever the result, you apply the square root. I get x squared equals to 46.71797. So when I apply square root, I get 6.83505 centimeter in this case. Do you get the same thing?
Yes.
Okay, good. Good. Now, I would give you this question, for example, let me create my own question. So for example, I have angle A to be 40 degrees, side A to be 12. No, not that one. No, not side A is not known. I want to have side B to be 12 and side C to be, let's say, 14. Now, with this situation here, which of side A or angle B or angle C can be found first? If you don't know, you can try to sketch the graph first. This is 40 degrees for angle A. Let's say this is B and this is C. So side C is 14, side B is 12. Now in this situation, which one part that I can compute first? You don't have a pair, so you cannot use law of sine, right? You don't have a pair, so you cannot use law of sine. What we can do is we use law of cosine to find the side opposite of this 40. Okay, that's what we can do first. Let me ask you to do that. I'll give you maybe 1 to 2 minutes. Cosine A. Let me just compute that right quick. 12 squared plus 14 squared minus 24 minus 14 cosine 40. Ooh, that's a big number. Oh, I typed it. Okay, this is that 82.60907. So my A will be square root of that. I get 9.08895. Is it okay so far?
Yes.
Okay, good. Now then the second step is then using that A, we will be able to find B and C, right? Okay. Once we get this, let me fill it up. So this is 9.08895. Okay, now then knowing this, we can actually use law of sine to find angle B. And actually we can also find angle B by using law of cosine.
Yes.
Okay, we can do both. Now, in this situation, which is better? In my opinion, it depends on the possible complication. Okay, if I use law of sine, there's a possibility I get two angles here. You see what I mean? There's a possibility I get two angles for the B's. If I use law of cosine, now you see law of cosine is actually longer, okay? But it gives you a specific angle. Now let me do law of cosine first, okay? So to find B, let me use a blue here. To find angle B, we can, one, use law of cosine, two, use law of sine. Now, because you have some freedom here, then you may get confused a bit when you do the test. While, oh, Thomas, I can use law of cosine. I can also use law of sine. So which one should I use? And then you kept on asking yourself during the test. No, just do something. Okay, just do something. The worst thing you can do during the test is not doing anything. And not doing anything is doing something. Okay, that's why the word nothing ends with ing. No, I'm kidding. Okay, so if I want to find angle B using law of cosine, then I need to have cosine B at the end, right?
Yeah.
So what is on the opposite? The opposite side, it has to be B squared. Remember that?
Yeah.
Okay. When I say that here, like C squared, like side C and angle C on the opposite, not only in this sense here, not only in this sense, in the triangle, but also in the equation. In the equation, angle C and side C are on the opposite sides. Okay, that's what I actually said there earlier. So then it will be A squared plus C squared minus 2AC. Is it right?
Yep.
And I plug that in. This is 12 squared plus my A squared. I already have that earlier. Plus C squared is 14 minus 2 times A is 9.08895 times C, which is 14 cosine B. Now that's what I compute. Okay, so this is 144. Let me see, what is it here? 82.60907 plus 14 squared is 278.60907 minus this is 254.4906 cosine B. Okay, don't forget, this is what I need to solve before I solve for B. Then I will move this chunk here to the left-hand side and this part here to the right-hand side. Of course, you can do it another way though. Don't get me wrong. So this will be 254.4906 cosine B equals to 278.60907 minus 144. That's 254.4906 cosine B equals to 134 something. So cosine B is equal to 134.60907 over 254.4906. I get 0.52894. So B is the cosine inverse of that number. I will still use the number I have on my calculator, which is 935 something. And that gives me B equals to 58.06645 degrees. That's if we use law of cosine. Now, suppose I use law of sine. Let me let you finish up the writing first. So sine A over A equals to sine B over B 40 sine 40 degrees over 9.08895 equals to sine B over 12. The law of sine is usually shorter, but the one I don't like from that, you may have two solutions and don't realize which one is actually the angle. Okay, so 12 sine 40 degrees divided by 9.08895. That gives me sine B equals to 0.84866. So B is sine inverse of that number. And I get B is equal to 58.06650. Huh? That's by rounding error, by the way. But that's B1 though. That's B1. B2, that's where it comes in. B2 is 121.93350. Right? There are two solutions for B here. There are two solutions for B here. Now, how do I know that this doesn't work? Right? I will not know. Actually, I will not know. I will not know. Because what? Because the angle 121, well, the angle is supposed to be 58 something, according to our law of cosine. It should be 58 point, what's that? 0.6645. Okay, but you see that we have extra solutions here. This guy, 121.933, 121.93350. Now, how do we know that we should reject this? See, we have three sides. Once you have three sides, then there will be only one triangle fit into that situation. It won't be two triangles. If you have three sides, that triangle is unique. Okay, so how do I know that this won't be the answer? How do I know that this won't be the answer?
The sides of the triangles.
What sides of triangle? So let's say I use law of sine, right? Okay, let's say I use law of sine. How do I know that this is not the answer? How do I know that I have to reject this?
Don't you compare the angles to the sides of the triangle, as you said?
Yeah, so what do you compare that? I mean, you just say that, but you don't tell me specifically what you compare to, right? You reject that because side C is greater than side B.
Yeah.
Which implies angle C will be greater than angle B. the notation. Suppose I need to change my notation a little bit. So side measure of angle C will then greater than measure of angle B, right? But if measure of angle B is 120 something degrees, then angle C is more than that. Consequently, angle B plus angle C will be greater than 180 degrees. Can you follow me, by the way? If you look back, side C is longer. Side C is longer, right? So if angle B is 121, then angle C will be more than 121 though. It will be 130 something, let's say, right? But if it is 130 something, then the sum of these two angles is already more than 180. That's where you get the contradiction. Okay. Now the thing is, I don't think during the test you can think that far to eliminate this B2. It's kind of a hard argument to make. Right? It's kind of a hard argument to make. That's why I say it is safer for you to use law of cosine, even though it may be longer. If you are lucky, then you can use law of sine and get the answer right away. But for sure, once you have three sides, there will be only one angle assigned to that side, to that angle. Once you have these three sides here, and once you have three sides, then it is a unit triangle. Okay. Now, implicitly, I have taught you the second application. What if we have three sides? What if we have three sides? Suppose I have this one. I have this is 7, this is 8, and this is 13. Let's call this angle A, angle B here, and angle C. Now, according to this picture, which angle is the smallest?
A.
Angle A, and the largest angle is?
C.
The largest angle is?
C.
C, angle C for cat, right? Now let me ask you then to compute, let's say, let me ask you to compute angle C. Compute angle C. Maybe 2-3 minutes, including your break. We come back at 6:00. So I need angle C. So outside I need to have side C. A squared plus B squared minus 2AB cosine C. So 13 squared equals to 7 squared plus 8 squared minus 2 times 7 times 8 cosine C. This is 169. 7 squared plus 8 squared. Let me just use calculator right away. That's 113. And then 14 times 8, 112. Now remember, we cannot combine these two here because they are not like terms. Okay, this guy has variable cosine C, right? While 115 without. Now Now, then what I will do, I think I will do this 169 minus 113 equals to negative 112 cosine C. I wonder what's that? 56. So negative 56 over 112 equals to cosine C. So C will be cosine inverse of negative 56 over 112. Well, that's cosine inverse of negative 1/2, by the way. So we know C will be 120 degrees. The reference angle is 60 degrees, right? But it is in quadrant 2. So C will be 120 degrees. Okay? With this said, then I can ask you to do some problems here regarding that. Suggested homework from 9.1b, the law of cosine case, from number 19 to number 20 to number 33. Number 19 to number 33. Yeah, make sure you try to do number 31 and 33. Okay, maybe I write it this way. Okay. Now, let me go on right below this. Let me go on right below this. A special, very special case, which is actually not really special. What is the angle, the area of a triangle with 3 sides known? Now, I will not do the proof anymore for this. I will just give you the formula, and it is called Heron's formula. Heron's formula that says that the area of a triangle is equal to the square root of S times S minus A times S minus B times S minus C, where S is semi-perimeter. Semi-perimeter, that is half of the perimeter. Suppose, for example, I have a triangle with 3 sides. A triangle with known 3 sides. Let's say that one question earlier. A equals to 7, B equals to 8, and C equals to 13. Find the area of this triangle. Find the area of a triangle whose sides are 7, 8, and 13. So the solution, first thing I will do is to find the semi-perimeter first. Semi-perimeter will be 1/2. It's actually lowercase s, not capital S. 1/2 of the perimeter, 7 plus 8 plus 13. I believe that's 14. So the area of the triangle will be square root of the semi-perimeter times semi-perimeter maybe minus one side, semi-perimeter minus another side, semi-perimeter maybe another side, minus another side, which will give me square root of 14 times 7 times 6 times 1. Now, unless the number is quite ugly, if the numbers are this nice here, all integers, I would like you to compute that with exact value. Okay, if you have decimals, then go ahead using your calculator. But if you have a nice number like this, I would like you to compute that using exact value. Okay, now, but then in between, you basically need to know how to do factoring. 2 times 7 for the 14, 7 times 2 times 3 for the 6, right? So you see, 2 squared under square root give me 2, right? And 7 squared under square root give me 7. Square root of 3. So the area is 14 square root of 3. Okay. Use calculator only when as decimals. Okay. Maybe I prefer to say it this way. If we have integers only, then get the exact solution first, then the approximate solution. Okay. Yeah. Otherwise, then you use calculator if the starting number is already ugly. With this, I think you can do problems from. There are actually a lot of interesting problems here, though. There are actually a lot of interesting problems in the later part. Unfortunately, they don't really give any problems to do that. But you will see this kind of problems in my old trigonometry class. And in my trigonometry class, and in my old test also for Math 260. Okay, now let me go on to the next section. I'm basically done with the trigonometry part for this course. I jump to 13.2. 13.2, or should I do 13.3 and 13.4? Yeah, that's what I do. Let me do 13.3 and 13.4 and 13.5. 13.4. No, I guess no. Let me do 13.2 instead. It's harder. 13.2 is harder. So that you have a weekend to study. Okay. So 13.4, 13.5 will still be in your test, test 4. In test 4. Okay, so we will learn this on Tuesday. And your test is on Thursday. You have only 2 days. But because they are quite easy, then I would just leave it up to Tuesday. 13.2 is harder, binomial theorem, binomial expansion. The binomial theorem. Now, the purpose of this theorem, one of the main purpose is, is to find the extension when we multiply a plus b to the n out. For example, we already know this one. We already know that a plus b squared is a squared plus 2ab plus b squared. Now, we already know that one. Okay. And of course, how about a plus b to the 1? A plus b to the 1 is just a plus b, is it right? And a plus b to the 0 is 1. Okay. Now, we already know that one. The thing is, I would like you to do, we will do some extension first, and then we will see some pattern. Okay, let me ask you to do the extension for a plus b cubed. That is a plus b squared times a plus b. Now, you already know a plus b squared is a squared plus 2ab plus b squared. So you basically need to FOIL this further. Okay, you just need to FOIL this further. Let me give you 1 minute. It should be enough. This is a cubed plus a squared b plus 2a squared b plus 2ab squared plus ab squared plus b cubed. That will be a cubed plus 3a squared b plus 3ab squared plus b cubed. Now, it is a custom in polynomial, especially if you have multiple variables, that we arrange the terms in alphabetical order. And since we have a and b here, I will do the a first, starting from the highest exponent, and the b starts from the lowest exponent. You will notice that the exponent will add up to 3 for each term. Okay, the exponent will add up to 3 for each term. Do you see that? Okay, so notes that first, number of terms, the number of terms is equal to n plus 1. Degree, the exponent n is 3, the number of terms, there are 4 terms. Okay, that's one. Second, the degree of each term, I think I should say the total degree. The total degree of each term is n. Third, the degree of base A starts from n down to 1. So you see degree of 3, degree of 2, degree of 1, degree of 0 for the n, for base A. But the degree of, I'm sorry, not down to 1, down to 0. The degree of base B starts from 0 instead. Up to n. Okay, so basically we have the following. So far we have the following. Suppose I have example 2. I have a plus b to the power of 7. A plus b to the power of 7. And you will see the first term will be a to the 7, right? Okay, plus something a to the 6b. You see that the exponent of a is decreasing and the exponent of b is increasing, right? Okay, plus something a to the 5th b squared. Notice that the exponent, the total degree has to be still 7, plus a to the 4th b cubed, plus a cubed b to the 4th, plus a squared b to the 5th, plus something a b to the 6th, plus b to the 7th. Okay, at least that's what we have known so far. At least that's what we have known. Now you will see what we will need to do later on is to find the coefficients here. Okay, now of course a plus b to the 7, the first term has to be a to the 7, no other way. And the last term has to be b to the 7. The coefficients for a to the 7 is 1. The coefficient for b to the 7 is also 1. The one I need to figure out is the coefficients for the middle terms. Okay, now I will leave it there for now. I will come back to that. Let me ask you to do the expansion for a plus b, maybe I give some space, a plus b to the 10. How many terms there should be?
11.
11 terms, that's right. Okay, I give you maybe 1.5 minutes. Okay, so for the terms that will be a to the 10 plus something a to the 9 b plus something a to the a b squared plus something a to the 7 b cubed plus something a to the 6 b to the 4th plus something a to the 5th b to the 5th plus something a to the 4 b to the 6th plus something a cubed b to the 7th plus something a squared b to the 8th plus something a b to the 9th plus some, oh no, actually just we know that this is b to the 10th. Okay, again, I will leave it late for later. We will come back here to find each one of the coefficients. Okay, I hope right now you can kind of like narrow down what is our issue actually for this expansion. Now, then let me go on. There's something called Pascal triangle. Pascal's triangle. It bears the name of Pascal, but it is actually quite well known, actually centuries even before him. Now, Pascal triangle has the following format: 1, 1, 1. This is the coefficient. This is the coefficient for n equals to 0, coefficient for n equals to 1. So if, for example, a plus b to the 0 is 1, this one here. Okay, and then A plus B to the 1 is just A plus B. It's this one and this one, coefficient 1, coefficient 1, right? Invisible coefficient 1. Is it okay? Now, the thing is, for Pascal triangle, we can actually extend it in the following way. We will always start from 1, and then the next part is the sum of these two guys here, and ends with 1. Okay, so you see that this is for n equals to 2, and it follows a plus b squared equals to a squared plus 2ab plus b squared, as we have known that earlier, right? You see these two, for these two here. Now, the thing is how to expand this Pascal triangle further. Now, the way we do it will be, it will start from 1, and then the next term will be the sum of these two numbers. The next term here will be the sum of these two numbers, and this guy. End it with 1. Now, that's for n equals to 3. So the expansion of a plus b cubed is equals to 1a cubed plus 3a squared b plus 3 plus 3 ab squared plus b cubed. Okay, and you can compare this to what we have earlier. Okay, you see we have 1, 3, 3, 1 for the coefficients, right? 1, 3, 3, 1. And you can develop this a lot further. So for example, if you want to know what happened when I did that power of 7 earlier, so this example 2, if I want to know that power of 7, you can just go to power of 7, even though I think it's quite a journey. Okay, this is for the expansion for 4. This is the expansion for 5. Right? I hope you see how I get these numbers. And you see that every layer I add, I go further, it will still form a triangle. Okay, and then 1, 6, 15, 20, 15, 6, 1. And of course, because of this, you will also see that the triangle that you have, every layer, it will be symmetric. When you read that from left to right, and when you read that from right to left, you will see the same order, the same sequence. Okay, now if I need that degree of 7, I just need to go one more, huh? So this will be 1, 7, 21, 35, 35, 21, 7, 1. 1, 7, 21, 35, 35, 21, 7, 1. This is the 1. This is the 1 here. 7. And then what else? 21, 35, 35, 21, 7, 1. That's the expansion. Now, of course, then we come to this issue. Oh, what happens if that's the degree of 20? Then do we need to extend this Pascal triangle 20 layers? No, we have another way. expanding it 20 layers will take too much time, that's one. Second, if you make any error computation, let's say here, then everything coming after that is wrong, right? So this quote unquote recursive method of finding coefficient of binomial expansion is too risky. It may be good only for the first couple layers, you know, maybe up to 4 or 5 layers. I think it's safe enough if you want to memorize. Memorize the procedure, of course. The procedure, you need to memorize this one, okay? But I think it's safe enough for us to memorize this, saying that, you know what, I memorized the 111, and then I think it's reasonable for me to extend it to 4 or 5 layers. Anything more than that, it's quite risky. Okay, so another method to find the coefficient coefficients is by using what we call combination. By using combination. Now, what is that combination? On your calculator, that will be the notation NCR. Look for that notation on your calculator.
Where do we find it?
On your calculator, look for the notation NCR.
Yeah, in like the mode or what?
That one I don't know. Depends on what calculator you use.
TI.
NCR. Usually, if you use TI-30, I think that will be under PRB. You need to press PRB first. There's a button PRB somewhere. Okay. Everybody, do you have that? Let me know. Do you find it, Jeffrey?
No, I have a TI-84.
Ah, so you're cheating using TI-84.
Huh?
So since you are using TI-84, that's cheating. I told you to use TI-30 or 36.
36.
Huh?
I don't have 36.
Yeah, then use TI-36. Use TI-36.
Where do I get that from?
Huh? Because TI-84 is graphing calculator.
Oh, okay. I'm sorry.
I said that in my syllabus, you don't use graphing calculator.
Oh, are you serious?
I am serious. Take a look on my syllabus.
Well, I thought all of them are graphing calculators.
No, TI-36 is not. And what I say in my syllabus is actually TI-30. So you don't use the calculator I asked you to use, but then you use other calculator. Now you ask me how to use that calculator.
All right. So,
Now, if you use TI-84, you need to press math first.
but I can't use it anymore, right?
Yeah, then do you want to get other calculator right now?
Sure, I guess.
Yeah.
Okay.
Yeah, but for now, assume you use TI-84. If you use TI-84, then you will press this math first. Are you with me?
Yes.
And then you move your cursor to PRB. And the third option is NCR.
Yes.
Okay, so the way you punch it will be, for example, later on, 7, choose 3. 7, PRB, NCR, 3. And then you enter. Okay. Now, by the way, for those who are using TI-30, it actually works the same way. You need to press the 7 first. If the n is 7, you press the 7 first, and then NCR, and then the 3, and then enter. Okay, now I go back. Oh, hold on. Come back here. Now, you see that 7 NCR3 give you that 35. 7 NCR3 give you 35. 7 combination 3. Is 35. Now, the way it works is actually the following. The one on the left-hand side here, this is 7 combination 0. So you start from 0, 1, 2, 3, 4, 5, 6, 7. This is 7 combination 7. Now, let me ask you to practice. Let me ask you to practice. I need you to know how to punch this. Okay, let me see who are here. Okay, Yuma, your job is to do, Yuma, your job is to do 13 combination 3. Carlos, your job is 10 combination 5. Tyler, your job is 12 combination 7. And then Malise, your job will be 11 combination 8. Manuel, your job will be, let's say, 9 combination 4. Who else? Nona,
Yes.
your job will be 8 combination 6. And then Jeffrey, your job will be 10 combination 7. Okay, each of you tell me what you get.
Okay.
Tell me once you have yours.
120.
165.
Hold on, give me a second. So Jeffrey, 120. And Melis, is that you?
165.
Okay, let me check. $165 is good. And then I get some message coming in. Okay, Manuel, 126. And Kyla, 792. Okay, that's the only two. Let me check Kyla. So that's right. And then Manuel. That's good. How about Nona? Huh?
Oh, never mind.
Okay, some of you were not really following me. I leave you behind. Okay. Anyway, that's how we do it. Okay, Nona, you figure out how to do that. Now then, so we will go back to our example 3. Actually, the one example 3 from up there, up here. Okay, now then the first term here has coefficient. The coefficient is is 10 combination 0. You can say the 0 here. You can say the 0 here. The 10 is from the exponent. The 10 is from the exponent. Okay, but the 0 here is the coefficient of b, the exponent of b. Now, 10 combination 0 is 1, right? Then how about this guy here? This will be 10 combination exponent of b is 1, right? Now 10 combination 1, you will see that's 10. Now then, let me ask you to use your calculator to find this. For example, what's that?
6 combination 4. No.
No,
10 combination 4.
10 combination 4, that's right. Now, 10 combination 4 will be 210. Okay, but actually, if you think about it, you can try this. You can try this. You will see that 10 combination 6 will give you the same value. Do you get that? What I want to say is this: even if you use, I say the 4 here is the exponent for b, right? But if you happen to use the exponent for a, you will get the same value, the same number.
Yeah.
Okay. Now, and therefore, for the same reason, this number will be 120 also, because this is actually 10 combination 6, right? So even though it seems like there are a lot of things you need to do, but once you do one, let's say 10 combination 1 is 10 here, then this will also be 10. Okay. Now, how about this guy?
Which one?
This one here. What is this?
Oh, 10 combination 8, which is 45.
10 combination 8 or
10
10 combination 2, right? Yes, that's 45. But if I know this 45, which other coefficient we know?
Huh?
If we know this is 45, which other term is 45? Which other term gives you coefficient 45?
A2B8. A2B8.
Okay, this one here. Okay, you can say that this guy is the third term from the front, must give you the same coefficient if you go the third term from the last. Okay, now this guy is 10 combination 3. I think that's 120. So this is one. Oh, I wrote this wrong. I'm sorry. I wrote this wrong. Oh, I have some dyslexia, I guess. It's supposed to be 210 there. Good thing I wrote that 120. So this is 120 here. Now this one is by itself. That will be 10 combination 5. That's 252. Okay. Now, notation. Notation. The notation I use here is a more recent notation. N combination R, where the N is a subscript. Maybe I write it down. Subscript and subscript, which means they are smaller and lower. Now, but this notation is a newer notation. In Asian country, they use this notation, NCR. At least when I learn it in Indonesia, I learned it using this notation. Okay, even though my professor and my teacher also say that even in older time they use this notation. Now, this is notation that our textbooks using. Not a fraction though. Without this, no, there's no this thing. There's no line here. No, it's not a fraction. Okay, it's just parentheses, one number on the top, one number at the bottom. Okay, so in your textbook, when you see this NR, for example, if you see 10 2 like this is actually the same to 10 combination 2, which I believe is 45. Okay, now another notation thingy, n factorial. N factorial actually means n times n minus 1 times n minus 2 all the way down to 2 times 1. So for example, let's say 5 factorial. It means 5 times 4 times 3 times 2 times 1. That's 120. Now, however, when the number's too big, let's say 9 factorial, it's harder to compute. It's harder to compute. You can use your calculator. You can use your calculator to compute that. And it's usually in the same category as the NCR. So I want 9 factorial, right? I go 9, go to math, go to PRB. And then you see option number 4, exclamation mark, and then enter. Okay, 362880. 362880. Or maybe I write the calculator notation here. Calculator. For let's say 10 combination 2, you will punch 10 and then PRB going to NCR. Oops. NCR, and then you punch 2 and then enter. Now for 9 factorial, you will type 9 first, and then PRB exclamation, and then enter. Okay, now I'm not done with this section yet, apparently, but there are some problems you can do already from our textbook. I would like you to do the suggested homework. Number 3 from this 13.2a, number 3 to number 3 to number, actually, let me just go on up to number 31. 31. Now, here's the thing. Suppose, for example, I do number 18. I still have 1 minute. Give me this 1 minute plus some extra. What we did earlier was a plus b to the 5th. Now what they ask is, so you mimic this, okay? What they ask is 3x squared minus y to the fifth. How do we do this? The way we see is the following. My a is 3x squared. My b is negative y. Okay, so the expansion of 3x squared minus y to the fifth is equal to a to the fifth plus something a to the fourth times b to the 1 plus something a cubed b squared plus something a squared b cubed. Plus something a times b to the fourth plus b to the fifth. Okay, now how about the coefficient? The coefficient is must be 1, 5 something, 1, 5 something, and I have 5, n is 5, so there should be 6 terms. But this will be 5 here, this will be 5 here. Now, how to get this number? This is 5c 2. Degree of 5, exponent of b is 2. You can also use 5 if you want. Now 5c2 is 10. So this will also be 10. Is it right? Yeah, 5c2 is 10. Okay, so the next thing is I will compute them. This is 3 to the fifth is 243 x to the 10 minus 3 to the fourth times 5 is minus 405 x to the 8y plus 270 x to the 6y squared minus 90 x to the 4th y cubed plus 15 x squared y minus y to the, I'm sorry, this is y to the 4th, y to the 5th. So I play with this color yellow, blue, so that you see the pattern. I basically replace the a by 3x squared and the b by negative y. But following that binomial expansion, okay, of course, again, we fall into the trouble of how to find the coefficients, right? Okay, but then once you get that, the last step is just combining them, put them together. Okay, that's why I give you this suggested homework here. Make sure you do that. Now, on Tuesday, when we come back, we will continue a bit more from here. Okay, a bit more from here, and then we will go on with 13.4 13.5. Okay, when you have a chance, maybe you want to read that 13.4 and 13.5. Okay, that's for today.
Professor, was my answer 8?